Hello, Mr. Malo here, your online math teacher, and welcome to my channel. Today we're going to be talking about how to use the law of sine to solve for angles and triangles, particularly focusing on triangles that aren't necessarily right triangles. So let's jump into this. So just like in previous videos on the law of sines that I've made, I have this formula here, and the version I particularly stick to is this one on the left. So if I want to see the relationship between an angle and a side length, it's sine of the angle divided by the side length opposite to it. That ratio is going to be the same no matter which pairing I pick. Now I can flip these proportions. That's all fine. It's fine to do that type of stuff. But this is the version I stick with, so you'll see me using this video. Particularly, we're going to use this to solve for angles in SSA triangles, as well as some situations after you've solved for one of your angles using the law of the cosines if you start with an SSS triangle problem. I will make note in those problems, if you're going to use the law of sines to solve for an angle and you have multiple angles you could possibly solve for at once, always solve for the smallest angle first. So that will be the angle opposite the smallest side length. It's just a little quirk of making sure you get the correct triangle with the information, because as we're going to see, the law of sines, in particular with SSA triangles, is called the ambiguous case for a reason. You could have more than one possible solution. So here's the first example of an SSA triangle we're going to look at that I have. And this is actually going to be one of our no solution cases. So as you can see with the information here, we know that side length A is 2, so I'm going to label that 2 on my picture. Side length C is about 2.12, and I have that angle A right here is about 145 degrees. And we can already see from this visual, which is to scale, that we're going to have no solution because this side length A isn't long enough to kind of swing down and map up with where side length B would need to be along that dotted line for A. We kind of don't have enough length to get there. Now, you can draw your diagrams, you can memorize and compare some things to try to see that we're in this situation. But I'm going to show you how we could set up with the law of sines and try to solve algebraically and still get to the same conclusion that we're going to have no solution. So in this case, we end up knowing angle A and side length A, so we can see we know both those. So that means I'm going to use that version of the law of sines first. So I'm going to put sine of angle A, so sine of 145 degrees over side length A, which is 2. The only other piece of information I have is C, so I'm going to put sine of angle C up top divided by side length C. Now, the only unknown in this formula is angle C, so my goal is eventually to get that angle by itself, but to start I need to get sine of C by itself before I can kind of unlock the angle outside of it. So to do that, I need to move away my 2.12. So I'm going to multiply both sides by 2.12 because that multiplication is going to undo the division there. And now I'm going to have that this is sine of angle C is equal to 2.12 times sine of 145 all divided by 2. You can still keep that 2.12 out in front of the fraction if you want. I just like moving it up to the top. And now I'm just going to apply inverse sine to both sides of my equation. And that is going to give me that angle C should be equal to sine inverse of 2.12 sine of 145 all divided by 2. And if you plug this into any calculator correctly, you should get an error message. And that's going to be one way to tell yourself you're in this no solution case. But this is going to be generally the same algebra we're going to use regardless of the type of situation we're in to solve for angles with the law of sines. And we get an error message because you can't plug in numbers greater than 1 or less than -1 into inverse sine. So let's look at an example that does have a solution now. So here's a one solution case. Again, I'm going to label my side lengths. Side length A is equal to 7.4. We have side length B is equal to 1.85. And we have angle A is 54. So I, again, can note I know angle A, I know side length A. So I'm going to start setting up my law of sines with exactly that. So sine of angle A is 54 degrees over 7.4. And the only other thing I have information on is B, so I'm going to set this equal to a sine of angle B over side length B of 1.85. Just like before, my goal is to get angle B by itself, but I need to get sine of B by itself first. So I can multiply both sides by that 1.85 to get it out of the denominator, because multiplication will undo this division. So multiply both sides by 1.85. That will cancel that. I now have sine of B by itself. So and this time I'll leave my 1.85 out in front to emphasize you don't need to move that number into the fraction. I just tend to like to, but sometimes I'll do this to emphasize you don't have to. So now I have this, and I just need to apply inverse sine to both sides, and I'm going to be able to get angle B back. So I'll get angle B should be equal to inverse sine of 1.85 times sine of 54 degrees, all divided by 7.4. And now we can just plug this into our calculator, and this is going to give approximately 11.7 degrees, And now that I have this angle and I already knew A, I could just subtract these off of 180 to get my third angle. And the last one I'm going to just quick. And finally, we have this two solution case of the law of sines. So what we're going to look at first is the first thing we're going to solve for is this larger triangle in red here. We're going to get our first angle with the law of sines here. So again, I'll start by labeling the sides of this triangle. I have B is equal to 51.1. Then I have C is equal to 64. And I have my angle B of 42 degrees in here. So just like before, I can start by setting up with the law of sines. So I know angle B and side length B. So I'll do sine of this 42 degrees over side length 51.1. The only other thing I have information on is C. So I'll do sine of angle C over that 64. Again, multiply the 64 away from sine of C. We need to get that by itself. So multiply by 64, multiply by 64. Those denominators will cancel. So now we have sine of C is equal to 64 sine of 42 degrees, all divided by 51.1. Now we can just apply inverse sine to both sides to be able to get angle C. So our angle C is going to be equal to sine inverse of 64 sine of 42 degrees, all divided by 51.1. And finally, we can just plug this into our calculator to get that angle C is approximately 56.9 degrees. Now, this is the ambiguous case for a reason. There is multiple triangles, so this is kind of our first solution. So first solution. And we could now go about finding the third angle in our first solution, because we'd have to just subtracting off 180 to get the third. But I want to focus on the second solution now. So the second solution. So in that case, we actually don't need to use the law of sines to get that second solution. But the second possible triangle is going to be this shorter one in here. Because if you notice, this side length B can kind of swing, has enough space to swing around the inside of our triangle here. So, and since B could be this 51.1 here, we see that the difference between these two triangles is an isosceles triangle. So that new angle C, that's going to be inside. So this new angle C, if I added that together with that old angle C we just found, that's going to create 180 degrees, because this is an isosceles triangle, that difference right there. So in our second triangle, our new angle C, that's just going to be 180 degrees minus our 56.9 degrees. And we can plug that into the calculator to get an angle of 123.1 degrees. So that will be the angle C in that second triangle. And again, Once I have this new angle C for my second blue triangle here, I already knew angle B originally. I can just subtract these off of 180 to find how much I have left for angle A. So this is my quick run through on using the law of sines in 3 very different examples. But when you're actually applying the law of sines to solve, you saw in each of these, the algebra and the math you did was pretty much identical. So I hope you found this video was helpful. If you did, like, subscribe, and we'll see you again in the next video.